Hi everybody, my name is Arya and I'm from TerraUnity team. Today I'm going to show you how TerraLand 4 works. TerraLand 4 comes with an advanced streaming system where it can generate huge and detailed 3D worlds in chunks, whether you are targeting a real-world style environment of cities including digital twins, or fantasy-style procedural worlds by filling your scene with artistic and stylish assets. Just select a location on Earth and give it your own desirable style and mood to the scenes. Okay, let's begin. As soon as you import TerraLand in your project, head into Tools menu up top and then open TerraLand section. Here you will have three different sections: TerraLand, Generate Streamer Component, and Reimport TerraLand. TerraLand is what I'm going to show you first, and then I will explain Generate Streamer Component. And Reimport TerraLand, as the name suggests, is used for reimporting the asset into the project. Okay, are you guys ready to go? This is how TerraLand looks like. Doesn't look like a nuclear core, right?
0.
So first we have to create a profile, God forbid not for Facebook, for TerraLand. As soon as you create the profile, you are going to view this screen. From the profile section, you can switch between the profiles that you already have or create a new one. Except for Profile tab, we have Generate, Editor, Build Server, and Settings tabs as well. Now, first I'm going to explain the most important of all, which is the Generate tab. Generate tab is consisted of two parts. One of them is Interactive Map, and the other one is Streaming and Static Terrain. The settings at the right side are Area Settings and Advanced Settings and Generate Bundle. In the left side, meaning the Interactive Map, has some options as well, which I'm going to explain them now. First of all, you have the satellite and land cover mode at the top right side. You can either view the satellite imagery of an area or the land cover map. There are some options on the left side too. You can disable the HUD or show area options, and you can lock area, which is used when you don't want to change your current area and view other parts of the map as well. And this slider on the right side is for zoom, which can be adjusted by your mouse wheel as well. Mouse position shows you the coordinates of where you are pointing on the map with your mouse, and map center shows you the coordinates of where the green cross mark is on your interactive map in the middle of the screen. Now, the only thing which is left from the interactive map is the search bar. You can head into any location that you like in order to bring its map and generate that area from the search tab. When you select a new location, like New York as an example, the data of that area is shown on their area settings, and a small circle appears next to the Generate Bundle icon, which means the software is loading the data of that area. In order to help you understand better, if we search Grand Canyon, as you can see, all that info on the right is gone, and this circle appears to load the area and the info. Okay, now it is time to explain the right side. On the right side above the settings, we have two modes. One is a static train and the other one is a streaming. As soon as you select the static train mode, except for the profile tab, all the other tabs get locked and the generated train will be in the scene and no prefab of it will be made. But in a streaming mode, all the created trains are saved as prefabs and can only be seen while streaming and not in the scene, unlike the static train mode. The created prefabs can be edited in Editor and be built in the Build Server tab as well. Area settings are the parameters for the area which the user selects. The first setting is Area Mode. Area Mode has two modes, Center and Size and Bounding Box. Center and Size shows the center and the size of your selected area. As an example, the coordinates of the center of this area is shown here, which is shown in the mouse position at the bottom of the interactive map as well. And our area size is also 4 kilometers, which is shown here. Our selected area is the green zone in the interactive map. Now, the other mode, meaning the bounding box, shows the coordinates of the four edges of the selected area instead of the center coordinates and area size. They are not very different from each other, they are just two different methods to select and demonstrate the area which is going to be generated. Now, WMS tiles. Pay some extra attention at this point. When WMS tile option is checked, one by one of the tiles are synced with WMS servers, so that the created train is synced with the database of other servers. When WMS tiles is checked, the area is generated by selecting the closest WMS tiles. In our case here, the selected area, which is the green zone, is created and carved out of these white WMS tiles. By changing the zoom level, the number and the size of the WMS tiles are going to be changed as well. And the maximum zoom level available is based on the available height map data. As an example, on zoom level 15, this area, as you can see, is created, which includes the green zone, which is our selected area. Now, these two info boxes, which you can see down here, one of them is the available data and the other one is generating trains. Available data tells us that the selected area, meaning the green zone, has 2K resolution data available on the server. And generating train section shows the info of tiles which are going to be created. So again, WMS creates the area by gathering the closest WMS tiles to the area which the user has selected. Now, if we remove the WMS tiles option, the exact same area that the user wants to generate is going to be created. As soon as you remove the WMS tiles, the zoom level option is removed and some extra options are added instead. First one is quality mode, which has 3 options: quality, performance, and custom. First, I'm going to explain performance mode and then the other options. Performance mode converts the area to tiles with a resolution of 256 pixels. First one is height map resolution and second one is texture resolution. As an example, the selected area is going to be converted to 9 tiles in each column and 9 tiles in each row, which makes it a total of 81 tiles. Now, second mode is quality, which is the same as performance. The only difference is that quality has more resolution compared to performance mode. Instead of the terrain with 256 pixels for both the height map and texture, it creates terrains with 512 and 1024 pixels. And last mode is custom, which lets the users to decide how many tiles and in what resolution they are going to be created. Tile grid shows the number of the tiles which the area is going to consist of. As an example, if you put the value on 1, the area is going to be made of 1 tile, and if you put the value on 2, the area is going to be made of 4 tiles instead of 1. 1 at the top right, 1 at the top left, 1 at the bottom left, and 1 at the bottom right. Height map resolution of each one of these tiles is 256 pixels, and so is their texture resolution. So the final terrain resolution will be 512 and 512, which you can see here. You can change these resolutions based on your needs. As an example, you can create 4 tiles with 512 pixels, which will create a terrain of 1024 in 1024. The next option, which is resample mode, has 3 different modes: automatic, down, and up. The data which is going to be used for the scene generation is going to be downloaded from a server. This data is stored based on a certain resolution and zoom level on the server. So usually the data which the user requires is between 2 certain zoom levels. One is above the required resolution and one is below. You can select on which data the terrain is going to be generated by selecting either down or up mode. When down mode is selected, the data with higher resolution is downloaded and it is resampled down to what the user has requested. And when up mode is selected, the data with lower resolution is downloaded and resampled up to what the user has requested. When automatic mode is selected, it calculates on which mode the quality of the output remains closer compared to the original resolution, and it downloads the best data available. Your area might be really close to the data with lower resolution, but because you might choose resample down, the software would download the data with much higher resolution. In this case, there's a high probability that more than 50% of your data which is downloaded might be useless. So automatic mode handles which mode is the best for your terrain. Area settings parameters are finished, so it is time to jump into advanced settings. Now is a pretty good time for a break too. No. Advanced settings is consisted of multiple sections, which I'm going to explain. First, the general section. Create imagery texture. When this option is checked, the terrains are created with a satellite image. As an example, as you can see here, the tiles have texture resolution as well. As soon as you uncheck the option, as you can see, it says no textures. Because now we are only creating the terrain, and terrain has nothing but a height map. Bathymetric data includes water data from Mount Everest to Mariana Valley. Use this option only when you need underwater data. It is recommended not to use this option in other cases in order to maintain elevation precision and accuracy. The elevation exaggeration value is between 0.5 and 4, and its default value is 1. It changes the Y scale of terrain and height map. As an example, when the value is at 1, a mountain can become a hill. Water scale is a value between 0.001 and 10. This option multiplies the terrain in the set value, meaning if we want to generate a 4 kilometer area, if we set the value at 0.001, that 4 kilometer area is converted and is shown in 4 meters and 4 in the Unity scene. Quality and resolution per tile. Well, this section is pretty obvious. You can change pixel error and splat map resolution from this section. If you are using a custom material for the terrain layers in order to paint them, it is recommended to increase the splat map resolution for better blending. Filters. Right now we have only one filter, which is a smooth filter, and as the name suggests, smooth filter smoothens the terrain. Iteration specifies how many times the smooth filter is applied on a terrain, and blending is also used to specify how much the original raw terrain is blended with the smoothened one. The last setting is terrain material under rendering section. Terrain material is the material which is assigned to all the generated terrains. TerraLand has a default material which you can change if you need to, and as you can see, this material is pretty simple and uses the standard Unity terrain shader. We're using Unity as a standard shader, but you can use your own custom shader as well. Okay, now that we know all the settings, let's generate something, shall we? Let's generate on static mode first, and put it on performance with WMS tiles. Now this is the generated area and it is viewable in the hierarchy tab as well. This area is the one which is shown with white grid lines in the interactive map. When you open this terrain, as you can see, there are 25 terrains below this one. So if we select this terrain, you can see it in the scene, and this is the tile which we picked in the interactive map. Each one of these terrains, besides the terrain and terrain collider, has T-tile info. You can find the coordinates of the top left and bottom right of the selected area in T-tile info. And it also shows that the size of the selected terrain is 990 meters in 990 meters. This was a static generation, and in a static generation there is more data in T prefabs under the assets. The main generated terrain has a date and time in front of its name in the hierarchy tab. And based on that date and time, we have a data folder over here which stores all the data for the created area. As an example, if we delete this texture, you can see that the texture of that tile is gone. I am going to delete the data and the area itself from the hierarchy tab in order to show you streaming. Now let's head over to the streaming system in TerraLand 4 by selecting the streaming button here. One of the important features of the streaming system in TerraLand 4 is that all team members and level designers can load the tiles from the server in edit mode, make whatever changes as desired, and finally upload them back to the server so that everyone can sync with the latest changes. Let's not use WMS tiles and generate the exact area on performance mode. Now that the area is generated, as you can see, there's no terrain in the hierarchy tab. Instead, we have terrain streamer. Terrain streamer streams the prefabs which are created. These prefabs are stored under assets, T prefabs, and under the folder with the name of the profile, which is test in our case. If you open the test folder, you can view the data and tiles folders. Prefabs are stored in the tiles folder. We can open and edit the tiles manually, or we can edit them from the editor tab. As soon as you open the editor, it will start loading the created tiles, and you can remove these white lines by removing the Show GUI option. We can select a couple of these tiles and open them in the editor, or we can select all of them. Right now I'm going to exclude the middle line. This box on the right side also tells you how to work with this tab as well. These are all the tiles that we selected, but if your area is big, you can't always load all the tiles because of performance issues. This terrain is now selected in the hierarchy tab, and you can see its info in T-tile info on the right side. And by terrain I mean the tile, this tile. Under the object in hierarchy is terrain itself, which you can edit. As an example, you can raise or lower parts of this particular tile, as you can see. Or you can add a game object to it as well. Besides adding objects manually, you can use a component or a script to add extra objects to the scene, like buildings, trees, or anything else. Once you are done, click on Save and Update in order to save your changes. After clicking on Save and Update, all the changes are saved on the server as well. All other changes for assets and resources in the project can be synced via Git systems. Now let's close the editor and head into the editor tab of the software. Wait for the editor to load, although if the tile that you want to edit is already loaded, there is no need to wait for the rest of the tiles to load, and you can select your desired tile and start editing it. As you can see, the box that we added to the tile on the corner is also updated and can be seen from the editor tab as well. We can select a single tile in order to edit it, and as you can see, it is updated and it is the same thing which we made earlier. Now time to head into the next section, which is streaming. In streaming you can increase or decrease the camera far clip, but right now we are going to increase it to 50,000 as an example. T-Terrain Streamer is also consisted of multiple sections: profile settings, camera settings, advanced settings, and gizmo settings. In profile settings we have one profile right now, but if we create multiple profiles, you can select your created profiles from profile settings as well. Camera settings. Camera is used to select our main camera. Visible range is for specifying the range which we are going to see the data, and if it is on custom range you can specify distance like 1000 meters, meaning all the data in 1000 meter range is going to be shown. And if you put it on far clip, it will use the far clip settings in the main camera. If frustum culling is enabled, anything outside the frustum of the camera is going to be disabled. Frustum multiplier is the multiplier which is applied on the frustum. Camera location is used to set the position of the camera at the beginning of the stream. The area which we generated is a big area, and your starting camera can be here or on the left or on the right or anywhere else. The default mode is the center of the area, and if you put it on Don't Override, it will not change the current position of the camera. There is one more mode, which is Custom Point. When Custom Point is selected, another button named Select on Map is added, which lets you to select any point on the map. Advanced settings has two time settings. First one is load time interval, which specifies the time between loading the tiles, since they are not all loaded at once. And second one is unload time interval, which specifies the time between unloading the tiles. Gizmo settings is used for debugging. The blue area is the frustum of the camera, and the more pale blue area is the culling FOV, which works based on the range radius that we specified here. If you check Always Show Gizmos, when another object is selected, gizmos will be still shown. When the settings are set, we can add a component to the main camera, which is named T-Player. T-Player lets you move the camera with WASD in the game mode. Okay, everything is set, and let's launch the game mode. At the beginning, you cannot move until the whole area is loaded. Now you can explore the generated area, and if you pay attention, you will notice that the tiles which are farther away than 1000 meters are getting loaded as we get closer to them in that range. You can change other settings like the speed of the stream and camera from T-Player as well. All the process that I explained here was for streaming in the editor. If we want to stream what we generated outside of the editor, we have to head into the Build tab. In the Build tab, on the left side you can see our profile section and some settings on the right side. Right now we have one profile, so we're going to select it, and there are multiple ways which we can build it. It can be built in with the setup file. It can be local, so that it is stored on a folder in one of your drives, which in this case the bundles which are going to be created are stored at this directory, and then the exe file will read the bundles from where this directory is set. And the last one is remote, which a directory is selected for the build and where the data is stored, and then a remote link which reads the data from the directory, which I will explain more further ahead. As an example, I'm going to select the local mode and leave the settings on the right side at their default parameters. Then click on Generate Bundles in order to start the build. The build was successful, and in the set directory we have 81 bundles, which are the 81 created terrain tiles. Now to the next step. Head into Build Settings, delete the scene, and add the current one. From Terrain Streamer, check to see if you have the right profile selected, and select the directory, then wait for it to build. The build is done. This is the exe file and these are the data, and there are two files with the size of 500 kilobytes in the streaming assets folder, which means that they are reading some data while streaming. Let's test the build. As you can see, this is the same area that we generated in the editor. Right now the exe file is in one specified directory and the data is in another one. So it worked fine, and time to close it. Time for the remote build. In this mode, you have to upload the build which is created in the build path to your load path. As an example, we created a folder in our host, so we copy the link of this folder into our load path. Once all the edits are done and the settings are checked and set, click on Build Bundles. Okay, build is successful, and now we have to upload the folder inside our build path, which is a standalone Windows 64, into our online host, which is the link in the load path. Now head into build settings and build the area. Okay, the build is finished now, so time to upload the zip file of standalone Windows 64 into our host. If you pay attention, the build itself is 279 megabytes, but the data itself is only 8 megabytes. So let's launch it and test it. We have to wait a bit because it is downloading the data from our host. And now, as you can see, the data is downloaded and it is being streamed. The last part is Settings tab, which has two sections. First one is Download and Cache Settings, which includes cache folder and shows you where cache folder is. In this case, it is in C drive and under TerraLand. You can delete the contents of your cache folder since it downloads data and might take some space. Download thread specifies with how many threads the data is downloaded. Show logs shows you any error or simple logs related to TerraLand, and don't worry about this error since it is already fixed. Writes login file documents all the logs of your project under cache folder in a file. And last one is profile settings, which you can delete a profile or rename it to whatever you like. And these are the scenes of a demo scene for TerraLand 4, which you will have access to the build really soon. Okay, that's it for today. Here's the end of our video. I hope you've enjoyed it. If you've had any questions, feel free to comment or ask them in our Discord server. Don't forget to check our website, our other assets, and if you already haven't subscribed to our YouTube channel, don't forget to do it.